Thank you, Anne-Marie and Danielle, for that terrific overview of RIFM's NAM's research strategy. And thank you, everyone, for joining the Strength of Chemical Clustering and the Legacy of Read Across. I'm Holger Moustakas, and I lead the chemistry team at RIFM.
I'm Jake Muldoon, and I am also part of the chemistry team.
Joining us today are Doctors Dan Liebler and Terry Schultz. They both have served on the expert panel for fragrance safety, an independent panel of academic experts that reviews RIFM's science. Could you briefly introduce yourselves?
Sure. I'm Dan Liebler. I joined the panel. I served on the panel for about 10 years. My background is in chemistry, toxicology, chemical biology. I was a longtime academic, University of Arizona and Vanderbilt. My principal role on the panel has been in sort of interpreting chemistry-related endpoint mechanisms, and then that I became heavily involved in the development of our read across approaches, which we'll discuss in more detail here.
Thank you.
Holger and Jake, thanks for inviting me to join this conversation. For those of you that don't know me, I'm Terry Schultz. I'm emeritus professor at the College of Veterinary Medicine at the University of Tennessee in Knoxville. I have a longstanding interest in developing methods for grouping chemicals and especially using them in data gap filling exercises. I joined the expert panel in 2013, and that was after I had been working for several years on the OECD QSAR toolbox.
Perfect. Thank you so much. So to start, I'd like to provide a brief background of how chemistry has affected the safety assessments at RIFM. So in the past, RIFM published large group assessments, and these assessments were generally based on 1 to 2 specific functionalities that were considered the most critical for those chemical and toxicologically significant features. These groups could contain as many as 40 or other chemicals as well, though. And what we realized as we started to approach these were that chemicals in these broad categories could have other chemical and toxicological properties, and then that group would be inappropriate for really comparison. So as our science evolved and the need for single ingredient assessments became critical, RIFM further refined its read across approach.
Now, writing individual chemical safety assessments for all fragrance materials was not a simple task. Most notably, not every material had sufficient data to validate its safe use. And restrictions on testing intensified this issue as in vivo testing on cosmetics ingredients was banned in Europe in 2013. Now, while some endpoints such as genotoxicity and skin sensitization had potential in vitro tests, others like repeated dose or reproductive toxicity did not. Therefore, with standard testing procedures not available and a desire to complete the evaluation of the fragrance inventory in a reasonable timeline, other methods were needed. And so this resulted in the formation of the chemistry team and the application of chemical grouping and read across.
So as many of you know, read across is a structure activity analysis that can assist in filling data gaps. Read across uses data from a structurally and metabolically similar data-rich material to predict values for a data-poor material. Employing chemical grouping allowed RIFM to identify materials that could be used as read across analogs quickly and efficiently. The RIFM chemistry team works closely with the expert panel for fragrance safety to develop and further the use of read across, from identifying how to select appropriate read across analogs to determine endpoint-specific read across rules. So with that background out of the way, I'd like to turn it over to Dan and Terry with a starting question. And that is, how do you think read across is still developing, particularly concerning the fragrance material safety process?
Terry?
Thank you, Dan. Over the past half decade, we've seen RIFM has made a concerted effort to expand the concept of read across from rigidly defined structural boundaries to ones that are more relaxed. And this was an effort to expand the concept of read across to fill a data gap where we need to have a chemical with experimental data in order to read across to the unknown chemical or the one that we haven't had tested. This is interesting because within the fragrance chemicals, of course, We have a very defined chemical galaxy that's just a small part of the chemical universe. And compared to other regions of the chemical universe, this is a very well-studied area. So there is ample uh, experimental evidence to help us with data gap filling. So I think that the advantage that RIFM has had is it's had a defined set of chemicals and they've been relatively data rich. So that's been very important. Another important principle that is important that has been used by RIFM is the fact that the number of identical features that you have between the untested target chemical and the tested source chemical, the greater the confidence you have that the prediction will be correct. And the advantage here is that even if you don't know the mechanism or the mode of action that's taking place, if you have these similarities, you have more confidence. And this adds to the overall weight of evidence into the arguments, which is something that has become more important over the past decade, or at least especially the last half decade. I guess the other important thing is the issue of uncertainty. There's growing agreement that increases in uncertainty strongly impact the acceptance of any type of read across or data gap filling exercise. Therefore, if you can reduce the uncertainty by improving the numbers and types of similarity arguments that you have, the more likely that these data gap filling exercises, such as read across, will actually be accepted. And I think those three elements of things that RIFM has really focused on and has made this effort so powerful within the fragrance industry. Dan?
Terry, maybe I could pile on to that and give a slightly different perspective of sort of how this developed during my time on the panel. So I joined the panel probably a couple of years before Terry did, I think. And at the time, there was really no read across. There was no formal read across structure, but we would have a material that had missing data, for a key data point, and RIFM's scientists for a particular endpoint might say, well, we've got data for this chemical here that looks similar. And I would be presented sort of on the fly with the question, could we use the data in a read across? Dan, what do you think? And I was the chemist on the panel at the time. And it would require me to basically use whatever knowledge I have to, on the fly, make a decision. Yes, no, we could do it. And then verbally explain, well, somebody took notes, why we could justify it. And it's actually good because it helped us clear some endpoints. But the problem is it wasn't systematic. And if I were to leave the panel and Terry were to join, or our colleague Trevor Penning, were to join, then you get a different chef making the assessment essentially. So it's not systematic, and it needed to be. And Terry joining the panel was a catalyst for a process and a system. And basically, there are two things that we do. The first was figure out what chemicals we have data for, what structures have been evaluated, and then to organize them in a systematic way so that we could say, well, this material we're reviewing right now has certain structural features. Let's go to our records and see what other similar structures we have data for. That was systematized by chemical structural feature, and that was published in a chemical research toxicology paper. That was critical. Then we had essentially a systematic way of going to the candidates for read across. The next key step was to say, all right, how are we going to select analogs and use them in the context of different endpoints, like reproductive and developmental tox versus skin sensitization, where the considerations are different, and a chemical that might be a read across for a material for skin sense might not be at all appropriate for repro or genotox. So that's when the second part of what we did, which was set in place a framework that's built around metabolism, endpoint specificity, and the knowledge surrounding those things. I see those as the two key milestones. And the reason I'm kind of recounting this history is because that's what the panel is still doing. That's how read across is selected and vetted. And in addition to those key parts, all the endpoint scientists on the RIFM staff are part of these discussions with the chemists on a weekly basis, I think. Weekly meetings with the chemists and the endpoint specialists were very important because they allowed us to constantly evaluate and develop the rules. And if I had a nickel for every time Terry said, write it down, I'd be a wealthy man.
Yeah, I think, Dan, what you were saying in the beginning was, the challenge of trying to make everything systematic. And especially, Terry, you as well talking about the uncertainty in order for us to get these read across analogs accepted in this case, and how do we reduce that uncertainty? And a question that I had for both of you is, what challenges do you think are facing read across now, and what do you think how we can overcome that?
Well, up to this point at RIFM, read across is really focused on the apical endpoints, that is the in vivo endpoints that are typically involved from a risk assessment or regulatory context. But we know that in the near future, that safety assessment strategies are going to change. They're going to integrate more human-centric types of testing. They're going to be combined with computational toxicology and chemistry. And of course, the second and third generation of in vitro toxicology and testing, whatever they may be, will come into play. So we're going to get a whole different series of data coming out. And the question will be, is how these novel data or novel endpoints going to be integrated into assessing chemical similarity and grouping and all those types of situations. So I think there's going to be room for read across. It's just going to be looked at in a context other than just apical endpoints. And the interesting part about that will be is how we actually are going to integrate those challenges and gaps that you get from using the next generation of endpoints into what we feel comfortable with right now. And I believe that that's going to be a near-term challenge or opportunity that we're going to see for read across.
Yeah, and I agree with everything you just said, Terry. And in fact, I would just emphasize the fact that there are different kinds of tests that are used that supply the data. And again, just in the context of skin sensitization, we've got everything from HRIPTs and patch testing to test tube chemical reactivity of a material. Those things are all complementary data. We have a kind of still off the cuff or on the fly way of integrating those. We are probably going to need more attention to a framework or a rule set for prioritizing different kinds of data. Last time I was involved in this, it was relatively, it was sort of done on the fly without clear rules. So again, it's a question of discussion, consensus, and then turning it into process.
Yeah, I think that makes a lot of sense. And, I think it honestly does lead right into my next question as we're starting to think of, the new tests that are going to provide data for us as we're starting to look at more read across. But so what do you think the future of read across is? What role will, machine learning and AI, as popular as they've become and as they've been developing the last couple of years, have in this field going forward?
Good question, Holger. I guess, first of all, I would think of it as that grouping and read across are not silver bullets. They're not the end all answer. So we're going to use other technologies, and these technologies are just in their infancy. So we don't have a lot of experience with them. Again, it's going to be, as Dan alluded to, is that how are we going to use this information to fill the data gaps? How are we going to prioritize one test versus another test in those types of situations? But as appealing as it was for read across to be important when we're doing in vitro endpoint to in vitro endpoint extrapolations or interpolations. I think that appeal will still hold when we get to the newer technologies that we see coming down the road. Another important thing that I see in way of read across, or at least in the way of how AI and machine learning could be used, this is, of course, the plethora of data that we have that has been generated in a very standard, uniform way within the 2,000 plus RIFM safety assessments on the discrete ingredients. There's about 600 more that have to be completed on that. But when you have that, you will then have 10 or 11 endpoints where each one of those endpoints was handled the same way for those 2,600 chemicals. That becomes a very powerful tool or data set with which to use to develop and validate particular novel tools that come up within the AI machine learning environment that we're seeing taking place in chemistry right now. So I think that the next generation of tools that we're talking about here are going to have to be innovative, they're going to have to be flexible, and they're going to have to adapt because we just don't know what the different the new technologies, what endpoints or what data are going to be more important than others at this particular time. So you need to be able to do all those things. With that said, I still believe that the issues of transparency and explainability are going to be critical, especially in the beginning, because RIFM is unique and we have many different committees or subcommittees, and it's a consensus organization. So you're only going to move as fast as the slowest member of the slowest committee on these types of situations. So data accuracy, data limitations, uncertainty will continue to be difficult issues that we have to work hard to resolve.
I think that AI and related tools, I'll include machine learning as part of the AI world. I think they're going to help us the most in contexts where there's too much data to keep in any one person's head at any one time, and inferential jumps need to be made, or at least comparison of the information in one data set to another data set. For example, just getting to navigating our clusters to pick the right compounds from the clusters is not a trivial thing, particularly in certain areas of our chemical space. The way we do that can be learned by algorithms, and that can assist again in making that part of the process more systematic and effective. And then, of course, navigating the different kinds of data supporting the chemicals for the different endpoints, again, is something where we currently handle it by experienced, knowledgeable chemists and experienced, knowledgeable endpoint specialists. But if someone's out sick or has a cold or something, the decision process is different. And I think the thing about read across that I would recommend we always keep our eye on is trying to eliminate individual bias from the process. And then everything else Terry said about transparency, making sure that the results are things that we could get up in front of skeptical colleagues and defend. That's still what we're as members of a panel and scientists working in the field, that's what we're responsible for. So all of this is essentially aids to helping us do a more even, consistent job.
Yeah, I think that's fantastic. I mean, when we think about it in this sense, it was mentioned before, over these years, I mean, Dan, you were on the team, and now, Terry, you've been with us too. Like, there's been thousands of different chemical pairings that we've done now over these years. And with these thousands of chemical pairings, some were more complex than others. Some were, easier than said than done, easier to explain, easier to have it in that sense. But I just was kind of curious, I'm kind of new to the team, and what were some of the most complex cases of materials that you've encountered, or really where read across is challenging, or more so, where has read across been groundbreaking since you've were a part of the team?
Terry, you remember more than I do.
Let me go back to 2006 or something like that, when we were talking about read across, because it came out in 2007 in the first document from OECD. And that was very much an interpolation. So if you had data for, let's say you had data for propanol and you had data for octanol, you could fill in a data gap for pentanol. I mean, it was that tight. And certainly we have now moved at least to where we consider it an extrapolation. The extrapolation might be within a classical chemistry concept like primary alcohols, or it may be with using metabolites, where we do with hydrolysis of an ester. But I think the thing that RIFM has brought forward in that is the willing to push the ceiling of read across from this very rigid comfort zone to a more expanded and flexible forms of similarity. And that has allowed us to really utilize read across and data gap filling to an extent that most other industries haven't even attempted to approach yet.
Yeah, Jake, I wasn't sure if I understood your question to be, do you remember a great chemical that was read across was a home run for? I mean, the tough ones are the tough ones. They're your heterocyclic materials with relatively few similar chemical substances, in the fragrance world, and there's not much to go on. And read across just doesn't help you there. I see read across often helping us when we have a material or a series of materials that are structurally very similar, maybe with different alkyl chains or slightly different substitutions, or even different isomers, and they're all different identifiers. And then we can hit upon the right read across to allow us to consistently evaluate all of them. And I think that's a little appreciated part of read across, is essentially being able to not hit home runs, but hit singles and do it consistently.
Yeah, I think to your point there, Dan, I mean, I think that's one of the strengths of the clustering that we've worked on and really refined, because we get to know those groups of materials that are similar, find the data in them, and really spread it across to really help us efficiently get through evaluating the safety of these materials. And I think to your point, Terry, too, I think that harkens back to the point before of, we're really being able to start to expand and be less rigid because of endpoint specificity, right? Really understanding what's key for all these different endpoints as we're starting to evaluate more and more read across, I think has really helped us push forward in developing it and understanding it even better, to have confidence in it. So yeah, that's really, thank you so much, Terry and Dan, for all of these insights. And of course, all the scientific work you put in to get us where we are today. For those of you with questions or who want to take a deeper dive into chemical clustering and the read across process, Jake and I will reconvene in a moment for the first of two related breakout sessions with the live Q&A, the future of RIFM's animal-free read across strategy. To access this and other breakout rooms, click on the Rooms tab in the menu at the top of your screen. We really hope to see you there, and thank you once again.